All right, now we're going to talk about infinite sequences. So, a function whose domain is just the counting numbers, 1, 2, 3, and so forth, the numbers we use to count, is called an infinite sequence. And the notation that we use for it is a set of curly bracket with an a with a subscript n on the inside. That represents all the y values of the sequence, all the y values. So if you plug in all those elements of this domain all the way up to infinity and put all those y values into a set, this is the notation we would use for that set. So the y values of the function are called the elements or terms of the sequence and are represented by a1 would represent the first term, or what you get when you plug 1 into the function. A2 is the second term, or what you get when you plug 2 into the function. A3 is the third term, what you get when you plug 3 into the function. And you can continue like that all the way up to infinity. So that's what those ellipses represent. An represents the general nth term. So an could represent A1, A2, A3, A4, A5, or A6, any one of them. So it just represents a general term. And you don't stop there, you keep going, because this is an infinite sequence. You plug in all the numbers all the way up to infinity. So the expression or rule for the function is what we give that notation, an, to. And it's called the nth term or general term of the sequence. So the function that we're plugging the numbers into, that rule or expression, is actually what we call the general nth term. So let's take a look at an example. Find the first 5 terms of the sequence with the given nth term. So here we have a rule for finding the values of a function, and what they want us to do is find the first 5 terms by plugging in 1, 2, 3, 4, and 5 for n. So for instance, a1 is -3, and now I'm replacing n with 1 plus 7. So it turns out that a1 is -3 plus 7, which is 4. That's the first term. A2, on the other hand, we just replace with a 2 here. A2 is -3 times 2, -6. -6 plus 7 is +1. A3, we just replace those with 3's. A3 is -9 plus 7, so A3 is -2. A4, the fourth term, well, that's -12 plus 7. -12 plus 7 means that A4 is -5. And lastly, we have A5, the fifth term that they asked for. So A5 is just 3 times 5 plus 7, or -15 plus 7. -15 plus 7 means that A5 is -8. So there they ask for the first 5 terms of the sequence, and there are the first 5 terms of the sequence with the given nth term. Just like plugging numbers into functions. It is just plugging numbers into the functions. So here's a second one. This one is an equals 48 to the -1/2 power, or sorry, 48 times -1/2 to the n-1 power. So that's not too hard. Let's see. A1 would be 48 times -1/2 to the 1 minus 1, or 0 power. That's equal to 0. When you raise anything to the power of 0, you get 1. So A1 is just 48 times 1. 48. All right, A2, let's see. A2, we just replace those. And instead of 1 minus 1 equaling 0, now we have that 2 minus 1 is equal to 1. So that's going to be 48 times -1/2 to the first power. So A2 is equal to -24. 48 times -1/2. All right, moving right along. Now we're we're changing. We're looking for A3 now. So A3 is going to be 48 times negative 1/2 squared. Negative 1/2 squared is positive 1/4. And 48 times 1/4, 48 times 1/4 is 12. So that A3 is 12. Moving right along, we're looking at A4 now. A4, let's see, A4. Well, A4 is 48 times negative 1/2 to the third power. 4 minus 1 is 3. Negative 1/2 to the third power is negative 1/8. And 48 times negative 1/8 is negative 6. And then the last one they want me to find is A5. So looking for A5 now. We just replace those with 5s. And that's going to be 48 times negative 1/2 to the fourth power. That's just 4 now. Negative 1/2 to the fourth power is positive 1/16. And 48 times 1/16 is just 3. So that A5 is just 3. And there we found the first n terms of the sequence. Now both of these terms were defined with the general nth term, which defines terms of a sequence based on the value of n. There's another kind of way to describe the terms of a sequence. While the nth term of a sequence expresses the terms as a function of n, a recursive formula defines the nth term as a function of the previous terms. So instead of n being in the expression, it'll be an or an minus 1, the previous terms. So let's see. Here's an example. It says find the first 5 terms of the sequence for which a1 equals 7. So they already gave me a1. They told me that a1 is equal to 7. So I just need to find 4 more terms. And then it says that a2 or an is equal to 2 times an minus 1 minus 3. So that means that if I wanted to find a2, for instance, a2 would be 2 times an minus 1, which is a1 minus 3. So in this case, that's equal to 2 times 7, which was a1, minus 3. 2 times 7 is 14. 14 minus 3 is 11. So a2 is equal to 11. And then we want to find a3. So a3 would be equal to 2 times a2, 2 times a2 minus 3. So 2 times a2 minus 3 will give us a3. But a2 that we're looking for is actually given as 11. We just found that. So let me see. 22 minus 3. So it turns out that a3 is just equal to 19. 19. All right, now we're looking for a4, the fourth term. The fourth term. So a4 is 2 times a4 minus 1, or a3 minus 3. Well, 2 times a3 would be 2 times 19 minus 3. 2 times 19 is 38. 38 minus 3 gives me that a4 is 35. And then the last one that they asked us for, a5, let me see. So a5 is going to be 2 times a4 minus 3. But a4, we already found out, was 35. So 2 times 35 is 70. 70 minus 3 is 67. So a5 is 67. And there we have the first 5 terms of this recursively defined sequence. And that's how we find the terms of a sequence.